Let's go through LeetCode 1192, critical connections in a network. For this question, it gives n servers and also list of list connections. It says that these servers, they are connected. And let's try to find all of the critical connections. So what is a critical connection? Is that if we remove this connection, the server will be into two sets. So let's take an example. If we have, for example, A, B, C, right? And none of this connection will be critical. But if we have D, if we remove this connection, right, then it separates the into A, B, C, and D two sets. So the same thing like if you have E, F, G, right? So we'll say this is another critical connection. So this question is a bidirectional graph to detect circle. So we can use the distance array to detect the circle. That for if we have distance next smaller than smaller than distance current. So why it is smaller than? That is because for bidirectional, if this A and B, just two nodes is not a circle, right? It's possible that we visit B and A and B. In this case, if we visit B first, we still have distance I plus 1 greater than distance next. So in order to form a circle, after we visit B, we need to have a visit C first, right? So in this case, we'll have A plus 1 greater than B plus 1, right? So we'll have I greater than next. The same thing, let's begin to compose the graph. New sub integer. Map equals new hash map. And for every connection, we compose a map from the connections. Because this is a bidirectional, right? So we need to have 1 and 0 as well. So we create a distance array. Let's set its value to be -1. So because it says that at the beginning, every server are all connected, so we don't need to use a for loop. So we can just DFS from node 0, right? So we have distance 0 equals 0 and DFS. DFS, we need to have the map. We need a current node. We need its parents. We need a distance array. And we need this result. We need to have a result. In the end, we just return result. Map into current, into parent, and distance array, and result. We can do the same thing, trying to see whether this map contains key or not. If not contains key, just return. But for this question, it says that every server they are connected. So that means every node, it will have some connections connected to it. So we'll say so for every node, it will be in the be one of the key in the map. So we'll say, of course, you can say if map doesn't contains key, right? Contains key, but we are not necessary. Yeah. So we'll say for if you write, it's not wrong. For int next in map get I. We'll have if next equals parent. We just continue, right? And then the other will be its child. So we'll say if distance next equals -1, or distance next greater than distance I plus 1. And that means we are in a smaller route. We'll have a distance next equals distance I plus 1, and then DFS map next I distance result. So as we talk about to detect circle in bidirectional graph, is that if we have distance I greater than distance next. So this is a circle, right? So for this question, what we are doing is that we are trying to backtrack, trying to see we'll see this next will be in a circle, and I will also in a circle, right? And the next will on a circle. So how can we make sure this kind of node I is in the circle? Is that we can use the trick to set the distance I equals distance next. Okay. And when we do this DFS, if the distance decreases, then we'll say it's in circle, right? So we'll say if distance I, so we need to have a initial value, right? So we'll have int this equals distance I. So we'll say if this distance smaller than this, that means this I is in circle, and also not the entry of the circle, because 1 is also equals, right? And also here, because we during the DFS we change the i's value. So here this value is not maybe changed by our next if condition. So we should we can have use this. So so we'll say if this one equals, the distance doesn't change. So for what kind of nodes it doesn't change? Is the entry and also those kind of nodes it's not in circle, right? And they doesn't change. Then we're going to put this I and its parents into our result. Not its next, because you see this is doesn't change, it's next. This is on circle, right? So this is not critical. So what we need is put its parent. Okay, and its parent can be -1, right? So we are say if parent doesn't equals to -1, or you can say I doesn't equal to 0. And we put this into parents.